So I was inspired by this Hilbert curve marble run on printables.com, this one. I believe the author provided like a the SCAD file for it as well, but I thought it'll be fun to like make the same thing in Blender. So let's get started. So I'm gonna try to replicate something like this in Blender. Okay. So the first thing is we need to generate the Hilbert curve. So if you search for Hilbert curve, you can find the Wikipedia page for it. And the way to generate it is you use what's called the L system. So if you scroll all the way down, you just apply these set of rules to generate the Hilbert curve. Okay. To do that, you can use Inkscape. So Inkscape, if you open up Inkscape, go to extensions, render, you can write your rules for L systems and it can generate the drawings for you. So let me show you how I wrote the rules. Okay. So if you go to the website again, you can basically copy the rules. So right click, copy, and then I'm going to paste it in Notepad. Okay, so the way the rules work is you have alphabets A and B, and then you have constants. F means forward, plus means turn left, and minus means turn right 90 degrees. Okay, so you can set the degrees in here, the left turn, the right turn, but for the rest you have to add your rules over here and you have to state your axioms over here. Okay, so we have alphabets A and B. Now we cannot use this as is because in Inkscape's L system, if you go to help, A and B also means draw forward. So we cannot use A and B. You have to use some other character that's not here. Okay. So let me replace A and B with something else. So we'll go to replace. So let me replace A with M, replace all, and B with N. Okay, and then we can't use this arrow thing. It should be equal to, and we cannot do two lines. But you can separate the rules with a semicolon. So these are my two rules. Okay, so I'm going to copy this now, paste it over here as my rule, and the axiom is A, so in my case that would be M. Okay, and then if you go back to your drawing, you can then click on live preview to see what it does over here. Okay, so this does not look like a Hilbert curve. I figured out that the negative sign here that I copied from Wikipedia is not exactly the subtract sign. So let me show you what I mean. If you go back to extension, render, L system, if you put a negative sign on your keyboard, you can see that these two are different characters. Okay, so we need to replace that in Notepad. So select this, go to search again, replace, and replace it with the actual negative sign. Okay, replace all. You can barely see any change here, but it has taken effect. So copy this new rule, paste it here. Okay, and then let's do live preview. So that's my Hilbert curve. Now you can adjust the order. So if you want to simplify it, reduce the order. If you want to make it more complex, you can keep increasing the order. Okay, we'll keep it at 4 for now. Click apply, close. Let me just delete the other one. That's my Hilbert curve. I'm gonna save this. So let me resize page to selection, and then I'll save this. So I'll save as documents. Okay, and I'm gonna call this Hilbert. Okay, save. Now we're gonna load this up in Blender. So I have Blender open here. This is version 4.0. So if you go to file, you can import SVG files. That's what we saved. So documents. So I have the curve over here. So let's delete the cube. So the curve is kind of small. So just press S to scale it up. That's somewhat reasonable. Now if you hit N, you can see the scale of the object currently. You want to reset it. So you want to apply the scale transformation that you applied. So click on object, apply, and scale. Okay. Now the next trick is to raise up the path just like we seen in this printable file. Okay, so it has to start from the top and then navigate all the way to the bottom. To do that, we'll use the geometry nodes. Okay, first thing, we don't want these sharp edges. We want to smoothen it out. So go to the modifier tab and add a generate subdivide surface. Okay, and you can increase it maybe to 3. Okay, so this will curve out the motion, curve out the path for the ball to roll easily. Now go to geometry nodes, and we're going to create a new geometry node. And the idea is pretty simple. You want to extrude the path up, so extrude. Okay, by the way, this is the curve object, so it shouldn't really work this way. The reason I believe it works is because we applied a subdivide modifier. So if I were to like delete this, see there's an error now. Okay, so Control Z. So since we applied a subdivide modifier, we don't have to convert the curve to a mesh. We can just extrude it as is. Okay, and then for the offset, you can add a vector. And you can adjust the Z height. There's no faces to extrude, so we're going to change this to edges. And then you can adjust the Z height the way you want. Okay, but we don't want all the points to go up the same amount. We want to increase the height of the starting point, and the lowest point should be the end of the path. Okay, to do that, you can delete this vector and then add a combine vector node, and we can adjust Z for each point based on its index. So just search for the index. Now the index is the order of the point in the curve. So this will be useful for us to like kind of define how the path is progressing. And you'll see that it creates a huge maze. It's because the index are like whole numbers, like 1, 2, 3, and also. You want to scale it down. So let me add a math node. And we're going to divide this number by some large value. So I think maybe 500. Yeah. Okay, so this is roughly what we want. If you want to still scale it, you can just press S and Z and scale it the way you like it. But for now, I think this is good enough for me. Okay. So the next trick is, so now you have the path, but the ball cannot roll on this. This is like a thin edge. Yeah. So the next trick is we're going to go to the modifier tab. Let me go to layout again. That's all we need the geometry modifier for. The next is we're going to do it with the modifier tab. Okay. So in the modifier tab, let's add a solidify modifier. Solidify basically solidifies any thin walls. So we have a thin wall here. You can add some thickness to it. Okay. The next parameter offset determines like at which side of the curve are you increasing or decreasing. Okay. So this is on the left side, you can say, and this is on the right side. We don't want to choose left or right. We want to be right in the middle of the track. So we're going to set this to 0. Now again, it's a thick wall now, but the ball cannot roll on the track. What we're going to do is we're going to remove this option called fill. So it creates basically the walls with the track right in the middle. Okay. And then what you can do is apply another solidify modifier. So generate and solidify, and then increase the thickness to your liking. Okay. We don't want to encroach on the path, so I'm going to probably set the offset to the outside. Yeah, this is the outside. Okay. And if you plan on 3D printing this, then this is the setting that you want to choose so that it works on your 3D printer. So this should be enough for me. So let's go up to the top of the path. So this is basically it. Now the shading is not that right, so you can right click and say shade auto smooth. Didn't do much. Okay. And that's pretty much it. So now we want to apply some physics to like do the maze run in Blender. In order to do that, you have to go to the physics tab and make it a rigid body, but you don't have the option yet because this is still a curve. So we need to convert it. Okay. So before I convert, I'm going to duplicate this object. Duplicate the object, and I'm going to hide the original for now. So if I need to make some changes, I can go back to it. Okay. For now, I'll select the duplicate and then I'll convert it into a mesh. Okay. Once you convert it into a mesh, you can click on tab and you can see the all the vertices have been created. Okay, now you have the option to make it a rigid body as well. So click on rigid body. This is going to be a passive object. It's not going anywhere. And for the collision, you don't want convex hull, you want mesh to get the most accurate result. And we can also shade auto smooth to make it look realistic. And now go into edit mode. I'm going to add a ball over here. So I'm going to select this point, then Shift S to add my cursor to the selection, then tab out, and then Shift A to add a UV sphere. So let's do a UV sphere at that particular point. You can scale it down so that it fits in the track. You can go to the top view and kind of like line it up. Just press G to like move it around. Yeah, that should be on the track. Scale it a bit up. Yeah, so that should be it. Just move it up a bit as well. Okay, and then make this also a rigid body. This is active. It's gonna move around. And for the shape, you can choose a sphere. This will, instead of a mesh, this would make it much faster, I guess, to calculate. And that's pretty much it. Now if you hit space, okay, so now we haven't really applied the scales properly. So once you do any kind of transform, make sure you apply the scale. So scale, this should be 1. Make sure the other one is the same. Okay, so press space now and everything is in place. Okay, so that's pretty much it, how to do like a simple track. Now this is not specific to the Hilbert curve. You can always go back to Inkscape and choose any continuous line that can be the curve that you want to convert into a maze like this. Okay, and yeah, that's pretty much it.